Hello everyone. So now it's our last topic of the biochemistry analyzer. So here we have some hydraulic system of it. Yeah, hydraulic system for what? For make it for make our engineer, our field engineer, they can do the troubleshooting very quickly. So that's why we must not only hardware, not only software, not only installation, but in case once there comes a problem, maybe the alarm, or maybe some leakage, or maybe something else, some troubles from the end user, we have to visit them. And when we visit them, we should know the hydraulic system. Otherwise, we have to bring everything with me, and we will be it will take too much time for troubleshooting, because we don't know where to start and where to replace. So that's why we have today's training of hydraulic system. Here we have four parts: overview, hydraulic parts, hydraulic system, and maintenance. So let's go back to the first one, overview. Overview is just you can after you open the machine, you will find some. You can see the pumps, right? This is the pump, and the degasser, ceramic pumps, valve, and a small big valve, small valve, and this is also the pump, right? Okay, and this is the filter, 8 millimeter filter, and don't worry, every parts we have the mark. You can see here, this is the label mark. So overview, this is just another side, seen from another side. So this side is okay. So this is just we remove the pumps, and we make it you check inside. We can see inside. Okay. And here is from back. We can see something more, like the connector. This is the degasser. This is from right, from left, and this is some this is the lamp inside, and also coolant system, and also this is the sample and the reagent, uh, the the component, yeah, and also some cables here. So hydraulic system is once there's some liquid, we call it hydraulic. If it's moving, and we should know where to move. We should know the direction. Is it running this way or that way? Is it what's the name of each part? And how can I do troubleshooting? And what's the principle of each hydraulic parts? So we should know these things. Okay. So after we remove some pump, right? We also can see this connecting. Yeah. This is a probe valve, and pump. Sorry, this is the pump to the wash probe interior, and this is syringe. Okay, this is where all installed pump. Yeah. And this is the peristaltic pump. To what? For what? For first washing needle. For washing needle. Pump to mix the wash, and a pump to wash probe external, and a pump to wash cuvette, and a pump to wash probe internal. So you can see the internal and external, we are using different pump. Okay. So second, this one, and this one, pump to this one. So one by one introduced. Yeah. Okay. Next. Oh, sorry. This is a hydraulic pump, liquid pump, NIDAC 12, and quantity 1, mix bar 1, and auto wash some 4, some 7. It depends your order. Next is liquid pump Iwaki from DC12 and a sample prop internal wash. And this is the valve SMC, and this is the small valve, two-way valve, and the normal close means if the power is on, the pass will on, and between the probe and the internal wash, the pump and the syringe. This is the pump and the Thomas. The brand is Thomas, and concentrated wash solution to the first washing needle. This is the valve SMC and the three-way. Remember, this one is different. Three-way for drainage, extra water from the wash station. One-way valve, single-way valve. You can see the direction. You can see this arrow from left to right. So the direction is from only from left to right. The water cannot go back from right to left. From the wash station pump to the wash station needles. So we have four. Totally we have 4 pieces. One-way valve. This is another kind of one-way valve for mixed wash and mixed wash inlet tube. And this is a water cooling pump. Voltage is 10 volt. Working with the radiant fan to cool down the liquid from lamp and the pattern. Ceramic pumps, and this is the capacity, and with increment 0.1 microliter. So from the valve to the sample prop. For sample, remember this is for sample. And this is the filter. You can see the filter. This is a 65 mil filter connected to the purified water, and this is 45 mil micro filter. Connect to before the syringe valve to protect it. And this is the wash wear for what? For prop external wash and a mixed external wash. For internal cannot wash here. Remember, internal is to wash some other place, another place. Yeah. And this is hydraulic part, the prop for sample and the reagent prop, connected to the Teflon tube from syringe. This is the mixer, physical mixer for mixing the sample and the reagent. And this is a degasser. Degasser reduces the chance of air bubble coming into the prop internal. So once this something wrong of this degasser, you will find that the prop cannot there are some air inside it. It will affect the calculating in the syringe. This is the washing needle. 4 water inlet needle, 6 water inlet. So ours is 6 outlet, 4 inlet. Okay. You can see upper there are 4 inlet, 1, 2, 3, 4, and outlet is upper. So one is in and out. Hydraulic system. Okay, here comes the very important part. You can see the hydraulic system. Just a moment is just for review, and here is for the single pattern. Single pattern means for the we have dual and a single. It depends your order. So do you remember the function of this machine? We are using we are using the light passing by the cuvette here, right? So you can see the light is passing by the cuvette. This is the cuvette. 1, 2, 3, 4, 5, 6 in one. 6 in one cuvette. And the inside, what should we put inside? we should put the sample, blood sample and the reagent sample, and then we make them well mixed. So before the sample in and after the sample after mixed, before mixing, before it's empty, that is only diluent, only pure water, right? And we put the sample, and after we put the reagent, you can see the it will change the color of the this cuvette. And if we mix in, you can see we can get another kind of signal. That is the light signal, right? So we using the signal to do the calculating to check the concentration of the sample, and and then give a report to the machine, right? So this part is the most important one. For what? For software and for calculating is here. So this and so this system is we call it reaction system. But our machine is multi-using, right? So what to do? If I want to do multi-using, then we need a cleaning, right? So you can see other steps from left or right for this part, except the cooling system for the lamp. Lamp is to sending a signal passing by the cuvette. So except this part, others is for service. Service for this reaction disk. So how to service? What should we service? We should service for the feeding the sample and clean the sample, and then again and again feeding and waiting and calculating, and after that cleaning. So this is the loop. So here I have one question. So how to do feeding the sample into the cuvette? By what? Now, do you have any idea, Salah? What part is doing the feeding blood sample? Hello? So which part is doing the feeding of blood sample and the reagent sample? Sample probe, right? So you can see this one is moving. This is the place. So if I need a blood sample, the sample probe will come back to will go to here and feeding the blood or feeding the sample, feeding reagent, right? So this is where is the power? Who is pushing the reagent or sample into the cuvette? Which one? So this is a syringe, right? So syringe is moving up and down. But before that, cleaning the probe, right? So we need the wear. You can see the wear. This is the wear. We need a cleaning the probe here. After cleaning, then taking the sample, and taking the reagent from that system, from that disk, right? We have another disk. So the blood sample and put it inside, and then cleaning, and then go to the reagent sample and take the reagent into the cuvette. After that, we use this mixer, put it inside the mixing, right? Okay, mixing. Okay, then measuring. After mixing, we do measuring. After measuring, we do cleaning, right? So, okay, just a moment I introduced the feeding, this assembling, just similar like the hematologist doing the dispensation, right? So next we have to do the cleaning. So we have cleaning station. This is a cleaning station. How to clean it? Because in the hematology machine we have chamber and we have drainage part, and that chamber is not consumable, right? So there's a hole at the bottom, and we have pump to pump the water out to do cleaning, right? But here the principle is different. We are using the wash station to do the cleaning. So you can see the pure water is come here. This is station here, right? We have 4 inlet. There are 4 inlet of the pure water, and we can clean in four cuvette at the same time. After that, we have the pump to pump in the extra water out of this chamber. So you can see the diluent in and also waste out. Also, both of them at the bottom. So this is the this system we call it a cleaning system or cleaning station, cleaning and drainage, but the drainage from top. So this principle is different uh, like our previous our hematology analyzer, right? So and okay, so now you understanding how it works. So let's go back to how does the pure water enter it. This is the container with purified water, and we have filter, we have the sensor to detect the status of the if it's empty, machine will alarm, right? And after the pure water, we go to the degasser. So why we need a degasser? For what? For remove the bubble. So why we have to remove a bubble? Why? For what? Because otherwise, yes, otherwise the result will be affected, right? If the water, you know the syringe here, right? You know the syringe is here. So look at here, look at this part. The air bubble will go into this syringe. Look at it here, right? Okay. So syringe. And also we have two-way valve here and the filter, and we have the just a moment. We are saying this is the degasser. After degasser, the water should be go up, right? So you can see this is the inlet pump, pumping the purified water out of the degasser and into the wash station to do washing. So in case something wrong of this valve, this is the sway valve. So that means there's no water at all for washing. It's empty. So remember the function of this valve. So this is the normal close, and the normal open, and this side is normal open. If there's no voltage, it's open. So if the machine is off, you can see the water will automatically go back to this well and change it in this waste tank, right? So the wash station, the water will automatically going down to here, and for the for we have two well. This place we have two well for cleaning, right? One is for cleaning the prop, one is for cleaning the mixture. Mixture, as I mentioned, it will also move to this cuvette for mixing, right? This is a physical mixing, and it is different with the hematology analyzer. In the hematology analyzer, we using the bubble mixing, and the bubble will going from bottom to up, and bubble will mix the sample and the blood. Sorry, we are mixed the blood and mixed with the reagent. Then we do measuring, right? So here we use a mixed bar. But remember, this is multi using. This mixed is multi. Mixed bar is we have many samples, right? So we have to cleaning. Cleaning by what? By the well. So the well is we call it a clean system. Clean system only for the prop, but external, and mixer also the external, right? So how does the well do cleaning? We need the pure water, right? So we need a pump. This pump we are pumping the water from the tank, from the gasser, and then pump it to here. So you can see the water is go inside from top, from bottom, and then go out from where? Go out to here, to the station. So you can see the water is moving up and to here and to the wash station and clean here, right? Same for the well of mixture. The water is also from the degasser and but controlled by the other pump, and pumping the water passing by the well and then going up to here. Look at it here. It will going up us, okay, and then go out to the pump, and then after to pump here. Oh, sorry, it's different. Pumping the air to here, go up. Okay, to here, and then next is for the okay. Next is for the after here. Then after the water go to the pump here, and then go to here. This is the cycling also going up. Remember, this is also going up. They are connecting together, so it will be degassing. So the water in the mixed bar, the water will go, the wastewater will go to the concentrated water. Okay. And okay, now the two well we already introduced, and here the syringe we also introduced. Then next, so here I have one question: why we need pure water to the diluent? Because diluent sometimes we also need diluting the sample, right? So we will take some pure water to here and inside it here to diluting and then mixed again. So we also need this two-way valve to do the diluting. So next, this is the clean system for this and the clean system for the cuvette, and also we have cooling system, right? Cooling system is for what? Why we need a cooling system? Because the lamp we are getting hot, and if the lamp is hot, the calculating system will not properly. So we must have a cooling system for the lamp, make it stable, and then the performance will be very stable. So you can see the pump here is pumping the water here, and pumping. Okay, it's pumping, and then from here it's a cycling. Okay. Just a moment. We are seeing the water. You can see the here is inlet. Okay. So this is the different. They are here. You can see the diagram here, but they are not mixed together. The water will not mix together. Okay. Continue. Mm. Next. Okay, just a moment. We are seeing the drainage of the two well is here. Look at here. This is the drainage system. Both at the bottom of the two wells there is a drainage. Look at here, and the drainage into this tank. You can see here is always on. Here is always on. Always open. So the well, if I put some water there, it will automatically go to this tank. Even I have a pump to pump in the water here. So maybe the pressure is very high, right? The inlet is high, but don't worry, we have the overflow. We have an overflow automatically, and go out. Yeah. So okay, here we have another tank. One is for diluted waste tank. The other is concentrated waste tank. So why inside? in the two tanks, we have another two liquid level detector for alarming. If they are full, machine will alarm. And why we need a two? Because the some concentrated waste tank is very very dirty. Why? Because the dirty is from where? From the cuvette. The inside are many blood sample, many reagent, and very very dirty. So this container, even the volume is not too many, but very dirty, and we need very carefully to avoid some biochemistry pollution. Okay, so we have to treat them carefully. Maybe it will bring some cost to the clinic, but only this container is should be very carefully. But this is a little not too much dirty. Maybe the treatment, maybe the cost is lower. Yeah. So this is the hydraulic system. So do you have any question? Mm. So how do you think? Mm, okay, maybe I forget one thing. Is the concentrated wash solution? Yeah. Yes. Here comes a question. Do you remember we have auto wash function, right? So why we call it auto wash? Because sometimes the cuvette is too dirty. Cuvette is too dirty, and then it need some stronger chemical cleanser to do the cleaning. So we have this pump that is a peristaltic pump pumping this high concentrate solution into the cuvette. Can do soaking and then cleaning. Yeah. So this is for that purpose. Okay, this is for that purpose. And so here comes the question: why we use the peristaltic pump? Why not use the liquid pump? Why? Do you know the reason? Okay. Any other reason? If we are saying we need a little amount of the liquid, right? So why don't I use the syringe or maybe a small pump? Here another reason is because of this solution is very strong, and we using this pump and to extend the service life of the pump. Other pump, if I put a liquid pump, maybe it works. Firstly, it's very easy to broken. So you will find the service life, comparing the service life from lease 4 and lease 6. You will find the service life for 1, 2, 3, 4, 6 is very less than here. Why? Yes, yes. Well, yes. Get damaged very easily just because of the liquid is different. Here only pure water, you know. Here only pure water. So even yes, yes. This is a concentrated waste. So that's why service life is 30. Is it's lower. It's lower. Service life is lower, and we should prepare. If I were field engineer, I will bring this pump. Yeah, very easy to be get broken. Yeah. Yes, also the tubing. Yeah, and you know, uh, some valve. You can see this is one valve, right? Three-way valve, two-way valve. That is very basic hydraulic system. And the filter, filter for what? For maintenance, and also the here, filter here, and also filter here. That is, we are saying we call it service kit. Service kit for biochemistry analyzer. Why? Because those things are easy to broken, and And the probe is very easy to be. Do you remember this probe is the inside is very small, it's very narrow space inside, very easy to block. So we should provide tools for cleaning. We have a small how to say that is a very small tools to punch in inside and make it open. Yeah, make the need uh, remove the clock. Yeah. Okay. So this is so now this diagram is much clear, and warm system is here. This is a warm system, and this is a reactive prop. Yeah. Okay. So maybe I think it is here. All is here, and maybe not difficult, much simpler than comparing to a hematology analyzer. This one is much simpler. Yeah. Yeah. If I need some more project, if I need some more items, I just change different reagent. Yeah. And using different project. Okay. So um, let's keep going. Keep going. This is a doula. This is a doula palette. So skip. We just skip. Similar. Very similar. But we skip it. Yeah. Of course. Of course. That is available. Yeah. But generally, it for saving the cost, maybe no need. Yeah. It depends the customer. So just moment. That is an overview of the hydraulic diagram. But here now it's much more clear. Hydraulic system including water pass, prop internal wash, prop external wash, mixed wash, water cooling, cuvette wash, waste collection and output. So you can find the six module. Normally is doing cleaning and cleaning, but mixing very less. Dispensing and others feeding, right? Reagent feeding and blood feeding is very less. So normally this machine is consuming cleanser a lot, cause consuming washing solution a lot, and consuming pure water a lot, and consuming reagent a lot, right? So come back to here, prop internal wash. So in this diagram, you will see how machine clean the internal prop. This is the pure water after degassing, and then the valve, the pump here. This is the remember why we have this arrow here, because this is the power of this loop. Okay, it will be pushing the pure water passing by the valve and to the syringe and to the prop. And where I have one question: where is the drainage pass? Drainage pass. Yeah, left or right? Yes, the right one. The left is for mixed bar. Yeah, mixed bar. So you can see this is directly to the container, right? So the waste will go here. Okay. So you can see if we are doing troubleshooting, maybe the probe is always very dirty or corrosion. So we have to check this route. We have to check this diagram. So what to check? We check the diluent. Check the pure water. Check the valve. Check the pump here. Check the valve. Maybe the valve is not open. normally, so there's no water at all going out from inside. Yeah. So water in the purifier comes into the gas. Okay. Next question is, how does this machine clean the water, clean the prop external? This is simple. From here in the well, internal is washed by the pump here, but the out external is washed by another pump, not this pump, another pump. Pump the water and wash the external of the prop. Okay, then cleaning here. This is drainage, similar like the internal. And mixed wash is, yeah, same, easy to understand. But the pump is another one, another one. Yeah. Okay. But remember, the mixture should be going down, cannot add up. Otherwise, clean nothing. Okay. Next is the water cooling system. Water cooling system. Do you still remember the purpose? Why we have to do the cooling, water cooling? Yeah? Correct. Very correct. So you understand it very well. So the water here is doing the cycling, right? Cycling. From and the direction is from left to right and up and to here. Cycling. This is counterclockwise moving. Okay, remember, right? Next is the coolant water supply and the water and the pressure inside of the coolant cube balance. This is the cube. There's a cube here. So how can I do the feeding? Because in this tank, the water now is doing cycling, right? But maybe after many times running, the water will reduce. So we need a feed supplying, right? So this is the same pump. Okay, same pump. Pumping the water and into this place, and then to here, and then drainage. So there are two functions: supplying the water and also balance the pressure inside. Right. Mm. Next is the cuvette wash. Cuvette wash, as I mentioned, we firstly we use the diluent. Where is the power from? Power is from this pump, and the valve should be open. NC should be open, right? NC is same, normally closed. So the power should be on, and then clean the 1, 2, 3, 4 cuvette. Yeah, right. It, so this is the procedures, and also in the first wash, we have to wash many times, right? So in the first wash, the concentration will enter inside, and the soaking and the wash cleaning. Okay. This is the waste water collection and output from here. Oh, you got it. Easy to understand. Last topic is the maintenance. For the maintenance, as I mentioned, there are many consumables and disposables in this machine. And normally there's one thing very easy to be dirty, very easy to be get dirty is the prop. So we use a piece of gauze dipped with alcohol and waste diluent or waste diluent to wipe the prop external like this. Mm. Please remember wear the gloves, okay, a piece of gloves, and use this one. This is also wipe the mixed bar, remember. Next, to check the waste liquid level inside, check if it is full. empty the waste tank. This is daily. This remember this is daily maintenance. Use a piece of waste tank to wipe all the 6 washing needle. Similar. And take out the filter. Clean the filter. Wash it by pure water. Weekly maintenance. Second, so weekly maintenance, we not only clean the filter, we also clean the waste liquid container weekly. Clean it. And remove the reagent and the sample disc and the dryer, the condensed water here. And monthly maintenance, clean the pure water tank and if any dust found inside the tank. Yeah. Use a cotton swab dipped into the alcohol or wash station to wipe the prop. Wash the wear and then mix wash wear. Yeah. Wash the wear. Wear here, wear here. Yeah. Remove the reaction disc and wipe the reaction disc component. Clean here. And wipe the rotor gently until no dust is found. Clean here. And replace the filter every 6 to 8 months. Replace the filter here, this one, every 3 to 6 months when it obviously dirty. Get the stainless. This one is the tools I mentioned for cleaning the probe. Yeah. But this is not every day. This just some alarm. Yeah, some corrosion happened. Replace the lamp if the software has alarm. Software give the alarm, so the working time is 2,000 hours. Remember, 2,000 hours. And the lamp is not easy to find. Please audit from Dymind. Okay. Then replace the sample probe if it is crushed, broken or bent. This one. Replace this one from here. Replace the mixture if it is broken, bent or frequently stick with liquid. And replace the tube when necessary. Some tube. Install the fan cover and clean the filter net. Half a year. Change the frequency proper according to different environment condition. Okay, thank you. So Lau, do you have any question? Hello? Any question? No, thank you. So the training is finished. Totally we spent, I think, about 4 hours, I think. Yes. So when you visiting the customer,